I'm Anton. My role at the moment is Principal Solution Architect with AWS, and this pretty much has absolutely nothing to do with what I'm going to be talking about today, so I'm barely going to mention AWS, if at all. Right? Prior to joining AWS, I was a chief architect for cloud security services for 6-7 years, right? And as you probably know, once you go into security, especially IT, cloud-related security, even if you change careers to restaurant management, you're still going to be thinking about security, right? So security is there to stay. Today we're going to be talking about OAuth2 and OIDC, and I'm super thrilled that we have like almost full room here, even though those topics are been around for ages, probably. Okay. So a quick show of hands. How many of you are on a technical side? Development, architects, etc. Good, good, good. Okay, business side. More like product, business. Okay, IT, more like DevOps, kind of. Okay, great, great. How many of you have seen the Aladdin movie? Not the new one, the original one from 90s, Disney. Okay, this one. Okay, awesome. This is one of my favorites. I was, I think, like 10 or 12 when I saw it for the first time. And this is the gist of what we're going to be talking today, right? If you remember the scene where Aladdin kind of, goes to Jasmine and say, let's go, I'm going to show you the world. And then he says, do you trust me, right? So with all of your experience today, what should the answer be? Of course not. Well, of course not, right? We live in trust no one times, right? You do not trust anyone today, right? When you're talking about cloud security and security in general, you trust no one. When you're building your applications, when you have users and protected resources, basically stuff that users want to access, but they need to authenticate in a way, you have a lot of questions. Should users trust applications with their credentials? So let's say you have a new, awesome falafel shop in your neighborhood, right? And they've built a mobile application or a web application. And they're asking you to create username and use your credentials. Or moreover, you're probably familiar with those. It's still pretty popular today. There are, without calling any names, there are those financial companies that tell you, we're going to improve your credit score, or we're going to tell you how to, boost your income. Just give us credentials to your bank account, right? Not a good idea. Probably not a good idea. So, again, when you're building those applications, remember, we live in this trust no one world. It's hard to trust no one, right? The idea is, if you trust no one, it's hard to collaborate, right? You do need to establish some sort of trust. So let's see how this works at my personal household. So this is me, imagine me, right? My amazing wife and our 2.5-year-old girl. This is probably happening daily, right? We have this protected resource at home called candy, okay? And, may I have a candy? 2-time winner of Father of the Year award, what would be my reply? Go ask your mom, okay? Obviously, go ask your mom. So, mom, can I have a candy? May I have a candy? Of course you can, of course you may. Mommy said I may. What's next? Should I give Alex her candy? No. Of course not. I'm 42, she's 2. I don't trust her yet, okay? So I need to do authorization check. I need to make sure that, the information she's giving me, right, is actually coming from a trusted source, okay? My wife usually not a big fan of me calling her authorization server, but, she's a chemistry engineer, so she calls me names as well. So once I get this authorization, I can actually go to that protected resource, right, grab that candy, and give it to the user, okay? I don't know if this is what happens, at your homes, right? This happens at my place all the time. And when I thought about it, I thought, this is a great example of how to explain delegated authorization, right? Without going too deep into technical details just yet. This is something you see pretty much every day, right? Whenever you're stopped by a cop, right, and they're asking for your driver license, they're just looking at the license, right? And they trust the authority that issued that license, right? So essentially your license is your authorization. In order to validate that authorization, they might take it to their car, run it through the system, have no idea what's going on there, but essentially they trust your license. When you're going to Costco, same thing, right? You have your Costco card. The validation process is much simpler, is, welcome to Costco, right? But in order to get that card, you had to give your address, you had to provide your details, right? Well, I don't think they have asked for a credit card, but essentially you had to do some sort of authentication first. If you're talking about applications today, mobile applications, web applications, any kind of applications, this is still very common, right? Create account for every single application in the world, right? Give us your username and password, and you know what happens, right? Everyone probably reuses the same password everywhere, right? So once you're compromised in one place, you're compromised everywhere. But this is becoming more popular as we speak, right? So instead of every single application managing their own users, it's common to delegate that to some authoritative source, right, or destination, authorization server, essentially someone who they can trust. And this is all about, do you trust me? Let's take this, into our today's reality. We're all building applications, right? It's hard to imagine an application today that doesn't have any authentication at all, right? You always need to have some sort of authentication. You don't necessarily authenticate users right away, right? You might wait till checkout, for example, right? Or you might authenticate user at some later point in time. But you do need authentication. When I was building, that was quite a few years ago, when I was building my first authentication/authorization service, this is the real picture of my desk, right? With all of those RFCs printed, right? Anyone familiar with those RFCs? Anyone here is weird enough to enjoy reading RFCs? Okay, yeah, okay, so I'm not alone. RFCs are no fun, okay, but they're there for a reason, right? Request for comments. They are a collection of best practices and standards, right, that you do want to follow, but my personal recommendation after implementing that for a few times, you do not want to implement them yourselves. So if there is one single thing you want to take away from this session today, that's my personal recommendation. You do need to have proper security, authentication, and authorization in your applications, but try not to implement it yourself. Delegate it to some provider, like, there are open source libraries that do that you can manage it, that you can run yourself. There are companies like Okta, Ping, Cognito for AWS, still work for AWS, right? But there are many managed services that do that. They do it great. They've been in this field for years. They read it daily. That's what they're known for, right? And they implement it. If that's not your core business, do not implement it yourself. Trust someone who knows how to do that. But even if you use a managed product like Okta, Ping Federate, Azure ADFS, right? There are quite a few. You still need to understand how it works, right? You don't have to build your own car, but you do need to understand how to drive it, right? You do need to understand how to change tires occasionally. You don't have to, but the more you know, the better you are at it. So today we're going to be talking about these basics. We're going to be talking about OAuth2, OpenID Connect, JSON Web Token, or also now known as JWT or JWT, depends who you talk to, and Bearer tokens. Those are open standards that a lot of companies that implement authentication and authorization products implemented. Okay, no pun intended. And in my opinion, it's critical to understand how they work to make sure that your environments that you've built, are using them properly, using the correct workflow, right? And even by using someone else's product that implements it correctly, you're not breaking any security concerns. Make sense? Any questions so far? Okay. So let's start with OAuth2. Anyone here already using OAuth2? Okay, cool, several. Remember that problem of delegated authorization and authentication, right? So that problem existed for some time, right? Let's say I'm building my falafel shop application, and in order to personalize it, I want to show users' picture there, right? Now, this picture might be coming from your Facebook account, but how do I, as a user, grant you permissions to grab that picture from my Facebook account without giving you credentials, right? And how do I, as a Facebook, actually know that the real user authorized that falafel application, right, to get stuff from Facebook, from my profile? Make sense? Okay, so OAuth2 was created. I think it started about 7 or 8 years ago, right? It became very prominent about 5 years, 6 years ago, right? It's an industry standard protocol for authorization. If you go to auth2.net, you will get a lot of text explaining what it does and how it does. But to summarize it, right, to grab the most important pieces, it's a protocol for authorization, right? It's all about simplicity, and it defines specific workflows. Or to put it differently, it's a simple authorization protocol defining specific workflows. That's, in a nutshell, OAuth2. It's a protocol. There are multiple implementations of that protocol, but essentially it defines how this authorization works. Since we're already talking about authorization, it's pretty critical to explain that authorization and authentication are not the same thing. They are very, very different. So authentication, it's a process of validating your identity, right? So, in my household example, that would be my wife looking at Alex, at my kid, and saying, yep, that's Alex, right? That's, not some neighborhood kid, right? That's her, right? I'm validating her identity. Authorization, that's why I'm validating or granting access, right? This is pretty critical difference, right, in this world. If any of you are new to this world, you're going to see it everywhere, right? Not to confuse authentication and authorization. Now, we'll be talking about authentication a little bit later, but to start with authorization, how do you represent authorization, right? How do you represent the fact that a user is authorized to do something? And obviously, in that representation, you also want to show what exactly that user is authorized to do. You don't necessarily have to mention who that user is. Imagine the power of that, right? Being able to prove that user is authorized without actually exposing any personal data about the user, right? When you're going to Costco with your card, they're not asking to see your passport or driving license or anything else, right? It's enough to authorize you to enter Costco. The way it is defined in OAuth2 spec called access token. We're going to be talking about tokens a lot today, and essentially think about it as a way to represent authentication. It's a token. Put it in a nutshell, it's a string, basically a string, that in some magical way that we're going to be talking about today represents authorization. OAuth2 defines several workflows. They call them grant types, okay? We're going to be talking about a few of them today, not going too deep into most of them, but just a couple. And the idea is each of these workflows, each of those grants, are supposed to address a particular scenario. So we'll start with authorization code. That's probably the most popular authorization workflow, most common. From my perspective, I would also call it most recommended, unless you very specifically have a use case that requires a different one, okay? So what's the idea of that authorization code? So keep that story with my kid in mind. There's a user that goes to a browser, and they want to get something from application server, right? Index HTML. Or they might be already looking at the front page, but there's a login button, right? Essentially, they want to get something from that application server, from that application, that requires access to this resource server, right? That's, let's say, Facebook with your photos, right? How to get that photo to the website. So they're going to make that request, and the application server will tell them, whoops, you're not authorized just yet. Not authenticated, not authorized. Because application server doesn't know anything about authentication, right? It doesn't want to know how to authenticate you. It's purely about authorization. What will it do is, since we're talking about browsers, and browsers are pretty awesome supporting HTTP redirects, right? It will send you a redirect to the authorization server. So essentially, you've probably seen this a million times. You click login button, and you're redirected to Facebook, Google, or whatever. Also common, a pop-up, right? A little bit more advanced user experience, but instead of redirecting you, it's a pop-up saying, log in with your Google or whatever account. So there's a redirect to authorization server. Now you, as a user, now you're not logging in with that application. You're logging in with the authorization server, with Facebook, Google, Amazon, or your personal authorization server. If you're familiar with the notion of identity provider, related. Okay, definitely related. I'm just not going too deep just yet. That authorization server will return a login or consent form or whatever. You're going to send your credentials, if you're not logged in already, right? So like username and password, and authorization server will validate that your credentials are okay. So essentially authentication is happening here, not here, authentication. Once authentication is complete, authorization server is going to redirect you in exactly the same way back to the application, right? HTTP 302, right? You're going back to your application. Now, at this point, authorization server will supply what's called the grant code, and that's where the authorization code name is coming from. It will supply a code that identifies that the user has successfully completed authentication. It is not access token just yet. Why? Well, because those redirects are not really safe, right? Browsers, I do not consider anything on the client side super safe, right? And passing that information in HTTP redirect, especially considering those might be cached in browser history, for example, or whatever. You might have some network logs along the way. Passing the access token here will still not be super secure. So it's a grant code. Essentially, authorization server is telling the application, this user completed authorization, right? But you don't have that authorization information just yet. What application server would do is it will go to the authorization server with this grant code, right? And it will receive back access token, right? The token that is required to represent that authorization. Any questions so far? Make sense so far? How does authorization server knows how to trust application server? Well, because this grant code is just flowing around through browser, anyone can steal it here, right? Why can't I have like an attacker here grabbing that grant code and just stealing the token? How do we establish trust here on this segment? Well, easy. There is a pre-registration process where you register your application with authorization server and you're getting a secret credential. This way, only application server can make this request. Okay, so there's a process before this whole workflow starts, right, that essentially gives your application a way to identify itself, and this way, this grant code cannot be stolen and used by anyone else. Now, once your application got token, yay, now we can actually go to the resource server and retrieve that Facebook picture, or whatever else do you need, right? With that token, you can go to the server, get data, you're gonna get data back. Now you can return the response. And we'll be talking about this segment in more detail as well. How does that validation happen? So this is authorization code. It has two major benefits. User, or in official terminology, resource owner, credentials are never shared with the application. You don't care how application stores credentials or any other security information because you're never sharing your credentials with that application. And the second part are tokens are never exposed to browsers. Browsers are, I don't want to say not secure, right? Because browser security is also a hot topic, improving every single day, but obviously browsers are less secure than servers, right? When it comes to keeping data secret. So tokens are never exposed to browsers. They are kept on the server side in a safe storage. Let's talk about the other workflow called implicit. Now, it starts exactly the same way. You have a request, redirect to authorization server. Authorization server gives you a login or consent form, and you supply your credentials, username and password. The difference with this workflow, and credentials are validated, obviously. The difference with this workflow is the fact that after authorization server validates your credentials, it redirects you back to the application. But instead of supplying the grant code, like in previous workflow, it will immediately supply you the access token right to the browser. Okay, right in the URL of that redirect, you will get the access token. This allows you to get the token in the browser and make requests to protected resources straight from the browser. Okay, now you can still send those tokens to server as well, but the token will be exposed all the way to the browser. Anyone sees any issues with that? Any problems with? Yeah, okay, good. So the problem here is while user, that resource owner credentials are still never shared with the application, tokens are exposed to the browsers. This is less secure, right? I did not plan on this, but while waiting here for about an hour and a half for my session, I've seen 3 open laptops, right, on desks around this venue, right, with, I think one had Outlook on it, others 2, I don't remember. So 3 left laptops, right? No one was near them, right? Essentially, someone left their laptop and went to get a drink, right? If you're in a browser, if you know developer tools, it will not take you a lot of time to steal something like that, right? And also, this can be stored in history, in browser history. I don't think any one of us wants to have other people looking at their browser history. So if you look at OAuth2 workflows in their docs, they're actually explicitly saying it's not recommended to use this implicit workflow. Okay? There's a better approach of doing that today. I got 2 links here, so you'll be able to read about that. It's a workflow that is based on the first kind of grant, the authorization code, but that can still be used with browsers and native applications. But I cannot tell you that this workflow, implicit flow, is not used by anyone. It's still widely popular, right? But if you look at the recommendation coming from OAuth2, you can see this section, right? It was a simplified flow, previously recommended. It's not recommended to use anymore, right? Let's talk about the third one, resource owner password. We're doing great on time. Okay, resource owner password credentials. Now, as the name suggests, it has something to do with the password, right? The workflow here starts similarly, but it quickly becomes a little bit different. So you're still gonna get, not authorized for your index, but instead of redirect, it's going to be the application that's gonna send login form and user to your browser, and you submit your credentials all the way back to the application server. This is the problem that I've been talking about for the last 10 minutes, right? I'm saying, OAuth2 is great because the application, that unknown local falafel shop, will never get access to your credentials, right? And this is great. So yeah, the third grant type in OAuth2 workflows actually goes against that, and it says that in some cases, right, you do want to have credentials going through the application server, right? From that point on, application server can get tokens with your user credentials. Essentially, it will send your user credentials to the authorization server or identity provider. It will get token back, and then, it's exactly the same as previously. So the benefit of this approach is tokens are never exposed to browsers, right? Tokens. But user credentials are exposed to the application, okay? This grant, this workflow is great for highly trusted applications. This is great where your application and your identity repo authorization server are actually what's called first party, right? They are part of the same organization, so your application does trust that identity server and vice versa. Okay, basically, you're okay with pathing credentials through the application. This workflow is also well defined in OAuth2, but again, use it only with highly trusted applications. Sometimes this workflow is used when your business, right, product or business, they require a very high level of customization. Essentially, when they're looking at this redirect round trip and saying, that's ugly. I want something super fancy, with bells and whistles. I want super custom UI, right, which will not be supported with standard OAuth2. Sometimes this is when that workflow can be used, but again, don't make security decision based on desired UX, obviously important, right? If you want to use this workflow, make sure it's a highly trusted application. Client credential is the last one. It's probably the simplest. What's important about client credentials is you don't have users, right? It's client credentials, it's not user credentials. Sometimes you have application A communicating to application B. There are no users involved, there are no usernames, passwords, right? But you still want to be able to properly authenticate and use the same OAuth2 technology. So client credentials is the workflow that is used in this case, and it's probably the simplest. This is where application server, remember that initial step that I've mentioned, pre-registration. Application server is pre-registering with authorization. So this is where your application server basically goes to authorization server, is saying, hey, those are my credentials. Those credentials do not represent user. Those credentials represent server, right? Application, non-human component, right? And you're gonna get tokens back immediately. and then you can retrieve the data with the token that you want. Tokens are not exposed to browsers because there are no browsers, right? It's a purely application-to-application scenarios. There is also a notion of refresh token. The idea of refresh token is how many times do you need to log into Gmail, let's say. What was the last time you actually logged into Gmail? For me, probably like 5 years ago, right? Same for Facebook, same for many other applications that I use, right? So tokens are by design short-lived, right? You want them to be short-lived, right? Because, long-lived credential, that's your username and password, right? But tokens are short-lived. But, if those tokens expire, I'm going to be talking about that as well. How do you actually get a new token without asking your users to authenticate from scratch every single time? That would be a pretty awful experience, right? If you go to Gmail or your banking application, and every 30 minutes it will ask you to re-authenticate, right? And sometimes those tokens can be scoped to 5 minutes. That would be pretty awful user experience. So in order to address that, OAuth2 spec also defines a notion of refresh token. Refresh token can be used to renew the access token without actually re-authenticating the user. It's a pretty awesome capability. You can, on most authorization servers, it's enabled as a feature. It's a very common feature. So when user authenticates, they're getting access token that is valid for, let's say, 10 minutes or 30 minutes or whatever. And refresh token, that can be valid for 6 months, 12 months, 10 years, right? Depends on the security settings of your application. These are the 5 common grants, common workflows defined by OAuth2. There are others, more advanced, more fancy, right? The new ones are being added. OAuth2 also allows you to define your own grants, so you can extend that spec. But these 5 are probably most common that you're going to meet in the industry. I got a quick slide here. I'm not going to go through all the details, but essentially I've summarized all of those grants, right? And when each one of them should be used, ideally when one, and also when some of them should not be used, right? You'll get those slides. I'll share them with the conference organizers, right? Or you can take a photo if you want. Now, so far we've been talking about authorization, right? But it's hard to authorize someone without authenticating them first, right? And if you look at OAuth2 spec, it very explicitly says authentication is out of scope of this RFC, right? It very explicitly mentions that we're not going to be talking about authentication at all. So that's the reason OpenID Connect was created several years after OIDC. The idea of OpenID Connect, you can go to the website and read everything about it, but to make it short, it's an identity layer that is used to verify the identity. It's built on top of OAuth2, so think of it as an extension of OAuth2. I would say in the industry, it's very common to use OAuth2 and OIDC, OpenID Connect, interchangeably today, right? Sometimes when you talk about one, you mean the other and other way around. Guilty as charged, I do it all the time, right? But officially, it's an identity layer that is built on top of OAuth2. And it gives you a new kind of thing, profile information. So previously, we talked about access tokens. You don't need to know my first name and last name in order to grant me authorization or not. You just need to know that someone else authorized me, right? But your application experience can be made much better if you do have that personal information, right? If you do know my first name, last name, my profile picture, my, list of friends, right, etc. Basically, my identity information. Now, a layer on top of OAuth2 to verify user identity and obtain profile information. OpenID Connect introduces a new concept called ID token. And again, we're going to be talking about tokens pretty soon. ID token, unlike access token, is all about identity, right? And the fact that those two tokens are separate is incredibly powerful. Now, officially, different security products, different authorization servers, sometimes they do allow you to inject identity information into access token, because for some scenarios, some customers, it's easier for them to manage a single token. So I wouldn't say that it's always strictly decoupled. No, it's not, okay? As a security guy, unfortunately, no, it's not. But The default is you have two different tokens, and they serve two different purposes. Access token is there for authorization, right? The idea of access token is you can make authorization decision without knowing anything about the entity besides the fact that it has access token. This is super powerful. Identity token, it's an additional thing, right, that essentially will give you information about that entity, the identity information about that entity. So imagine you're getting access token and identity token in your application, and now you need to submit those to third party, right? But as a user, I'm not a huge fan of the idea that you're submitting my identity information to the third party. Well, you don't have to. You can just submit the access token, and that should be enough. That's the idea of having two tokens. So to summarize, OAuth2 is an authorization framework, and access token represents authorization, optionally as JWT, which we're going to be talking about in a second. OpenID Connect is authentication layer on top of OAuth2, and ID token represents authentication, always as JWT. Optionally, always. I think I've mentioned those tokens in JWTs for about 5 million times now. So let's actually talk about what JWT or JWT is. Anyone here already using JWTs in any possible way? OK, cool. OK, more hands. This is good. There is no official logo for JWT, unfortunately. So this is what I got. OK, it's a spec. There are no logos for RFCs. So that's the best I can do. Let's go through the same exercise. Compact, securely transmitting information, JSON object, verified and trusted, and digitally signed, right? You can read the whole thing there at the top. This is a snippet from the RFC. But the idea is it's a compact, secure, and digitally signed JSON object, much more than just a JSON object, right? It's much more than that. But to keep it simple for now, JSON object, that can be trusted. Now, why it can be trusted? Any guesses? Why I'm declaring that I can trust those JWTs, JWTs? Well, because they're cryptographically digitally signed by the authorization server, right? If you're familiar with public key infrastructure, the authorization server is the only entity in the world that holds the private key, and they can sign that token. Tokens are immutable. There is no way to modify, right, to change information within that token. The only thing you can do is to generate a new token, okay? Tokens are completely immutable. Anyone can validate those tokens because validation is performed using public keys, but only authorization server, that trusted entity, can actually sign those tokens, thus confirming that they're coming from a trusted source. So JWTs are so their content is 3 elements, right? 3 segments: header, token payload, and token signature. They are separated by dots. Keep that in mind. I'm going to show you a real JWT in a moment. You'll see those dots, right? Header and payload, they are base64 URL encoded JSON objects. So essentially, any information you want, there is a spec describing what information needs to be there, but you can add additional information. But they are JSON objects, base64 URL encoded. Signature is the digital signature. There are different algorithms for that, right? We're going to see it. A good example of that would be header, algorithm RS-256, right? Type of the token is JWT because spec talks about JWTs, but you might have any other type sometime in future. And KID, key ID, that's ABCDE. That's the identifier of the key that was used to sign that token. Because one authorization server might actually have multiple keys, right? And they're used for different purposes. But essentially, header, think of this as a HTTP request header. It's a metadata, right? It's a collection of metadata about that token. Payload is a little bit more interesting. Subject, right? That's your user identifier. It can be username, it can be email, it can be GUID, it can be whatever you want in your environment. Name, scope, company, and many other claims. I'm going to show you an example in a couple of slides. So essentially, payload contains identity information, information that you want that token to hold. Base64 URL encoded essentially means this is what it's going to look like over the wire when you send those tokens over the wire. making it a little bit more interesting, and line breaks here shown only to simplify the reading. This is what this token is going to look like. Base64 encoded header, dot, base64 encoded payload, dot, digital signature, okay? And this is what a real JWT looks like, okay? It's a long string, right, that you can first split by dots, note the dots here, split by dots, and then you know what exactly to do with each segment of JWT in order to retrieve the information. First, you validate the signature, right? Obviously, you want to make sure that this JWT is coming from a trusted source. Then you base64 decode the information, and you use that information. If you're not familiar with JWT.io, anyone using this site? I mean, I probably go there daily. This is awesome web tool for debugging JWTs. Everything happens on the client side. As far as I know, they never send anything to the server side, so the stuff you put in the browser stays in the browser, as far as I know, right? It's a great tool to debug your JWTs. Essentially, you paste either a JWT and they immediately decode it, or you can change this part, the text part, and they will immediately encode it. Amazing tool. I highly recommend it. Probably one of my to-go tools when dealing with JWTs and debugging authentication or authorization. I'm not going to be talking about AWS a lot today, but essentially, if you're familiar with Cognito, that's Amazon AWS's authorization, server authentication and authorization service. So it was easiest for me to pull screenshots from tokens coming from Cognito, right? This is what real Cognito access token looks like. You can see subject, and that's identifier of the user. You can see token use claim. This token should be used for access validation. You can see the scope here. Scope denotes what's the authorization scope. For example, whoever holds this token is authorized to read files and write files, right? But not to delete files, right? And there's a lot of additional information. Same for ID token, right? You have claims like X, that's expiration of the token. You have auth time, that's the authentication time. You can see here at the bottom that some claims are common, right? You do have a collection, a subset of claims which are common in identity token and access token, in both of them. And that makes sense because, first of all, well, you do need to know who's the issuer of both of these tokens, right? What's the authentication subject? What's the identifier of that user, right, of that subject that this token belongs to? Who's the audience? You don't only know who the user is who's authorized, who these tokens represent, but you can also define what's the audience for these tokens, essentially which resource servers are allowed to use that token. And other resource servers, according to the spec, they would need to reject that token, right? Issued at, unique identifier of specific token, etc. Other claims are token specific. So for example, scope is unique to access token because scope represents authorization scope. In the scope claim, you put the information that talks about what this token bearer is authorized to do, right? Email is unique to ID token since it represents authentication. I have email here. Interesting. Yeah, that's my work email. Now you know my work email. Awesome. Okay, so, but, there is no reason to put email into the access token, right? Because you don't need to know someone's email. You don't need to authenticate everyone. You don't need to authenticate someone in order to authorize them, right? You want to delegate that authentication to some trusted entity. That's the idea of OAuth2. Now, the last topic for today, I've mentioned a couple of times that whoever bears that token, whoever holds this token. Now that we know where tokens are coming from, the last question to kind of complete the picture is, how do you validate the token, right? So we've talked about how to retrieve the token, how do users authenticate, what these tokens look like, but how do you actually validate them on the resource server side, right? How does the resource server validates that? And obviously, there's a spec that talks about that, right? And we've just covered 4 out of probably, 50 different specs that are available in this area. Bearer tokens are a predominant type of access token used with OAuth2. And to put it simple, it's just type of access token. Predominant, I honestly do not remember more than 2 cases in last 7 or so years that were not using bearer tokens, right? That we're using tokens in a different way. And I'm not talking about 2 out of 10, I'm talking 2 out of hundreds probably, okay? So it's the most common token type, at least from my experience, right? Again, everyone's different, but that was my experience. This spec, the bearer token spec, essentially defines how do you use that token and how do you validate it. That is it. So the workflow is pretty simple. Your application server will already know that it has access token, right? It goes to authorization server to get tokens, it gets tokens back, and you have that access token, A, B, C, D, whatever. Now your application server needs to make a request to the resource server. So token bearer spec essentially says that in your HTTP request, you need to add HTTP header called authorization. It needs to start with bearer, white space, and then the content of that token. Essentially that base64 encoded with dots and everything. Why base64 encoded with dots? Because it's easy to pass over HTTP wire, right? Because it's not binary. It's a textual representation. Now resource server knows that once it's getting this authorization header, bearer, and the token, it knows how to address that, how to resolve that. It will grab the token, it will validate the signature, and validation fails. Okay, what happens in this case? Spec defines that in a very clear way. In this case, you return back 401 unauthorized. There are some cases where you can return 403, forbidden, right? But essentially, it's going to be mostly 401 unauthorized. And in the response headers, you're going to say authenticate, bearer, scope equals whatever was the missing scope. Why that authorization failed, right? Essentially, you need to explain why that validation failed, okay? If your application is built according to the bearer token spec, it knows how to handle that, right? And the best part is you don't need to handle that yourself. You don't need to implement that yourself. There are a plethora of open source libraries that do it for you, right? So OAuth2, OIDC, token validation, it's probably one of the most popular technologies out there for authentication and authorization. If you go to that JWT.io website, they have a library of different open source libraries, right, that can help you with token validation and additional related things. Now, if validation is successful, you're going to get back data, right? It will not tell you validation is successful. There's no reason for additional round trip. Immediately, you're going to get back the data that you've asked for. Okay, that's essentially the essence of that token bearer spec. So to summarize, there are 4 major parts to implementing authorization and authentication. Yes, there are more, right? This technology is ever evolving, right? So we've covered today, in a visual way, what are these workflows that create the baseline of this technology. They are OAuth2, that's the authorization framework, OpenID Connect authentication framework on top of OAuth2, JSON Web Tokens or JWTs, structured and secured way to store and transport information. Essentially, that spec talks about how do you build those tokens. And the last one, bearer token, talks about how do you pass that token over the wire and how do you validate it on the resource server side. To bring everything together, right, this is what in general, right, the workflow looks like. Step 1, you authenticate and you're getting tokens. You might have a user, it might be application to application scenarios, but step 1, you authenticate and you get tokens. The technologies you use here are OAuth2 and OIDC, right? And you can pick one of these grants or use any other. Step 2, you validate and you read those tokens. So once you receive that token, you probably want to validate it, right? You want to make sure that it's coming from a trusted source. This is where you do token validation. This is where you might read claims. If that's an identity token, now your application can present, hello Anton, right? And that's your picture. And do you want us to send some spam email to the list of your Facebook friends, for example, if I authorize that? Step 3, that's where your application can send tokens. And this is done through bearer token spec in authorization header, right? So this is using those tokens to talk to protected resources. And the last step is you need to validate access on those protected resources. You need to validate that whoever claims that, hey, I'm holding this token, right, and it authorizes me to do action A and action B. You need to validate that that token is coming from a trusted source. You need to validate that that token is not expired. You need to validate that that token was contains proper scopes, that token was issued for a particular protected resource, a little bit less common, but still important, right? So this is where you use bearer token plus JWT specs, and you do these actions. This is all I have today. Okay, I hope this was helpful, okay, useful. And if you have any questions, I'll be happy to take them right on time. Questions about candy is also welcome. Okay, so do you have maybe scenarios, like use cases, where you think this will be applicable, right? Do you use any of these today? It would be interesting to hear if anyone already uses this today. Yeah, go ahead.
In your opinion, where do you see the most misconfigurations of OpenID or OAuth?
Misconfigurations. Let me think about it for a second. That's a good one. So let me take it this way, right? This route. It's not that complex to configure the whole workflow, right? Once you did it once, right? You understand that you have those client ID and secret, right? And you have the callback URL. Once you did it for the first time, subsequent attempts are always successful. The first attempt, you need to understand the workflow, right? Because this exchange of, well, where do I redirect the application, that callback URL, right? So I do see some challenges in the initial configuration phase. That's why major authorization service providers, like they're working hard to improve that experience. Some of them are actually automating this, right? Some of them are providing out-of-the-box workflows that you can use this for development, but you'll have to go through this configuration for your production application. But for development, you don't have to, right? Because we've simplified. So that first initial configuration, and I'm not talking about every single time you need to do it. No, just the first time. This is where I do see people still struggle a little bit. Okay, but I hope those arrows, they will help you to understand what needs to be configured. One more thing is, well, again, try not to make that too complex, but in some scenarios, you have multiple hops of that authorization. So you don't have a single authorization server. Imagine you have enterprise SAML product that is 50 years old, and everyone is people afraid to touch it because it works, and you don't touch what works, okay? And you need to create an application that will go through a more, a newer product for identity provider, right? That will federate to that SAML, and that SAML might actually federate to yet another hop, right? So when you have a sequence of those authorization servers, SAML provider, right, identity providers, implementing different specs like SAML versus OIDC, this is probably complex part, right? This is getting into complexity area, and I do see misconfigurations there quite frequently, I would say, right? I hope this helps. Mm-hmm. Okay, cool. I'm sticking around. I'm not leaving. So if you have any questions, you can find me on LinkedIn. You can find me over here. Thanks a lot.